Good evening, Kavya. Anush, good evening. Teja, good evening. Thank you, Peter. Yaini, Sri Bhavni, why you are not attending offline classes? Huh? Sri Bhavni and Nandini. Corona went, beta. Examination is coming. So the most important thing is right now, write the exam, prepare for the exam. So just forget everything. Corona will not affect anyone now. Kaushika, good evening. In this question, match it. First question for you today. Kaushika, good evening. Just 1 minute. I will run away from that place. Give me 1 minute. I'm hiding the question. Just give me 1 minute. Fine. Okay, moving. Now look here. First question is fuse wire, bulb, higher power, potential driver, potential divider, lower current, rheostat, higher resistance, parallel, series, lower resistance. Now match by using your brain. First question, Shiva, good evening, beta. Good evening, Shiva. Shall we start our work, please? Akshaya, good evening. Shiva, good evening. Everyone, good evening. Ready, everyone? So the first question is, in between I will give another questions also. In between I will give another questions also. So come on, quickly tell me. Ready, everyone? Fine. Fuse wire, bulb, higher power, potential driver, lower current, rheostat, higher resistance, parallel, series, lower resistance. First one, match. Start matching the answers, huh? Start matching the answers. Fine, start matching the answers. I'm just moving in one side. I want you to attend the question. First question, first is B. Akshay is telling first answer is coming as B. Fuse is higher resistance. Eboki, join first everything. First answer is, Teja is telling first answer is calling as fuse is lower resistance. Others are also there now. Lower current is there, potential divider is there, higher power is there, bulb is there, fuse wire is there. So now think very nicely. I'm just telling you to think very nicely and then take a decision. Okay. So sometimes small things will become more. So here fuse wire, when you are going to connect with higher resistance, then another one I don't know the answer. Right now I don't know the answer. You think and say. You think and say what answer is exactly going to be the correct answer. Fourth answer is a potential divider. Exactly, potential divider is rheostat. Potential divider is rheostat. Potential divider is rheostat. Okay. Come on, I can take that 1 point now. Potential divider is rheostat. Okay, let's take that point. Potential divider is rheostat. Okay. Potential divider is rheostat. Fine. Now look here. Potential divider is rheostat. Potential divider is rheostat. 4-1 correct connection came. Next one, please. Then 1D. 1D, fuse wire connected in series. Okay. Bulb. What is the work of bulb? Come on. You can start. You can do it. You can answer. See, look here. Bulb. Parallel. lower resistance, higher resistance? I have no idea. I don't know anything. You have to exactly tell the answer. Okay, one answer is coming as D, two answer is coming as C. So bulb is connected in parallel. Okay, higher resistance, higher power, lower resistance. Higher power, lower resistance. Okay, I think higher power, lower resistance. Lower current, higher resistance. Hey, lower current, higher resistance. Lower current, higher resistance. Lower current, higher resistance. That's it. We exactly nailed the question. If you are checking it very nicely, then we know some things like fuse now, it is always connected in series. What is the need of connecting fuse in series? If one will be fused, if one means one will not work, then fuse will exactly one of the appliance, all the appliances which will be exactly, they have a fuse and the fuse is connected with them in series. If one of the fuse appliance will have some short circuit and some problem will be there, then what will happen? It will exactly, the fuse will exactly breakup will be there, and because of that breakup, what will happen? We can avoid short circuit or we can avoid some type of accident. So that is a very important, current inversely proportional to resistance. That is absolutely correct, beta. Bulb is exactly connected in parallel. Okay, if bulb will be connected in series, then it will become very dim. So connection of bulb will be parallel. Higher power, lower resistance. Power is inversely proportional to resistance. P is equal to V square by R. So power is inversely proportional to resistance. Because of that, we can say that higher power, lower resistance. Potential divider is exactly rheostat. Very good. Now exactly rheostat is what? It is variable resistor where you can change the resistance of a circuit. Variable resistance where you can change the resistance of a circuit. Fine. Lower current will be exactly higher resistance. Lower current will be higher resistance. Come on. We can go for the next question. This question I don't know the answer. Second question is, name the charge responsible for conduction in a conductor. Is there any charge movement in a wire under normal condition? Is there any charge movement in a wire under normal condition? This question very sensibly, take your time and give me the answer. So match question anyways you will do, but this question I want everyone to first think nicely and then give the answer. Name the charge responsible for conduction in a conductor. Is there any charge movement in a wire under normal condition? Is there any charge movement in a wire under normal condition? Think very nicely and then give an answer. Under normal condition, is there any charge movement? Is there any charge movement in a wire under normal condition? Good evening, Renu. Is there any charge movement in a wire under normal condition? Any charge movement in a wire under normal condition? Akshaya, electronegative charge, yes, there is a movement. Okay. Fine, we'll talk about it. We'll talk about it. We will talk about it. We are 100% going to talk about it. So first we are going to check this one out, how much it is exactly going to be acceptable. How much we can accept this point first. How much we can accept this point. Electrons, okay, no movement. Shiva is telling no movement and Shiva is telling it is electrons. Fine, Shiva is telling it is electrons and it is exactly having no movement. Okay, Shiva is talking about no movement. Akshay is telling electron charges are there, but there is a movement. Fine. So now I'm just going to go to the most important point. 100%. See, look here. There are two. The old concept says that current moved from positive terminal to negative terminal. But after the discovery of electron, we came to know that it is not about positive or negative charge. It is exactly the movement of electron from negative terminal to positive terminal. So movement of electron from negative terminal to positive terminal is exactly constituting current. Current. So 100%, the first part of the question is ki yes, name the charge responsible for conduction in a conductor. It is the electron which is responsible for conduction of current in a conductor. Is there any charge movement in a wire under normal condition? See, look here, one or two charge, if it is exactly moving, it is not possible for them to conduct current. You know what what one very important word I am going to use you. One word is called as drift velocity. Okay, I'm just explaining this point. So but not net charge will be 0. Yes, 1 or 2 charge, if it will be moving, it is not. See, look here, there is a word called as drift velocity. I'm repeating the point. There is a word, I hope everyone is present, those who were present in afternoon. So there is a word called as drift velocity. Abhirami, Annie, what is the meaning of drift velocity? Because the evening class I didn't discuss about drift velocity. See, look here, when potential difference is generated in a circuit, understand this point very nicely. So what is exactly the meaning of drift velocity and what is electromotive force? Okay, and with the help of that electromotive force, you will be understanding that under normal condition, does the wire carrying current or the wire is not carrying current? Then you will be saying under normal condition, wire is not carrying current. Then the question will be coming, the wire is exactly having free electron, then why in normal condition the wire is not conducting current? What is the reason behind? In normal condition, wire is not conducting current, but when you are exactly putting a cell or a battery, at that particular moment the wire will start conducting current. So what makes the things changed? Okay, so, or sorry, I'm just used that word. What is exactly changing the thing? So here you have to understand that the potential difference generated between the terminals, positive and negative, potential difference generated between the terminals. So what happens this? So there is a chemical reaction taking place. So this chemical reaction is exactly doing what? Formation of energy will be there. Now this energy will be providing a drift velocity. Drift means a type of push. So if you will be standing, I will be standing, until and unless I will not push you, you will be standing, but suddenly I'll come and I'll push you. What will happen? You will move forward. Yes or no? So that is exactly called as drift velocity. That is electromotive force. So this potential is exactly generating a drift velocity. It pushes the electron. So once the electron push will be coming, yes beta, potential difference is generated. So you have to understand this new content I am teaching you. I am teaching you the most important thing, that why exactly electron moves. What is the reason behind movement of electron? When we are exactly connecting a cell or a battery in a wire, then your answer will be that definitely inside, once the circuit will be closed, in the cell or a battery there will be a chemical reaction. So these chemical reaction generates energy, and this energy will be exactly pushing the electron. That is exactly the way the electron will be exactly getting pushed. It is a type of generation or putting a drift velocity, okay, or you can say electromotive force, EMF. So this electromotive force, Kartika, good evening beta. So this electromotive force will exactly push the electron from one terminal towards the another terminal, from one terminal towards the another terminal. So it will keep on exactly started moving. It will keep on moving. So that means under the special circumstances, what is the special circumstances? Till battery or cell will be connected and it will have that reaction, the electrons will move, because the electron is exactly getting that drift. That is exactly getting the push. But one day what happened? The cell or the battery will get discharged. Then will there be a conduction of current? Then one or two free electron, they can move, but they are not getting that appropriate amount of drift. So they are not getting that appropriate amount of drift. So are they capable of doing conducting current? No, because they are not be able to let the circuit to, they don't have that much velocity called as drift velocity to exactly complete the circuit. So since they will not be exactly having that velocity, they won't be able to complete the circuit. Because of that, there will be a no net charge there, no net force will be generated. So there, in normal conditions, it cannot conduct electricity, and only when you will be applying potential, they will be getting the drift or electromotive force. Because of that, the electron will move. I hope my children might have understood. I hope my children might have understood this simply concept. In simple concept, I tried to let you understand. You understood this point? Tell me fast. You understood this point, that there definitely some reaction is taking place. Key point first, reaction taking place. These reaction generates an energy. This energy is exactly trying to generate a force. This force will be exactly providing a drift. This drift is nothing but a type of push to the electrons, and the electron will start moving from negative terminal towards the positive terminal. In a very simple and content. We have just tried to understand this point. Oh, I hope you might have understood this one. Come on, quickly tell me. If you have understood, then we will go for the next point. So there will be, in normal circumstances, no net motion will be, the net motion of the electron will be 0. The motion of the electron will be there when it will be exactly having potential, where it will be exactly having potential. What happened, I told you morning itself that you have to be very active in today's class, and once you are not understanding, you have to ask me, because over and over first electricity chapter we have to just finish. So come on, I want my children to just fast answer the questions. In offline class, how much you are active, same way I want you to be active here also. Come on, tell the answer. Did you understood this point? Yes, Akshaya, no movement will be there. Absolutely correct. Teja understood. Okay. Come on, I want everyone to be super active today. Shiva understood the point. Teja understood the point. Super. So now shall we go back to the next content? Because see, topic by topic I am just covering the most important points. I am just telling. Shivavni understood now? So this one more time you just understand, but just these are very, very important questions. Now third question is when two ends of a metallic wire are connected across the terminal of a cell, some potential difference is set up between its end. In which direction electrons are flowing through the conductors? In which direction electrons are flowing through the conductors? In a very simple way, you just have to answer the question, which direction electrons are flowing through the conductor? In which direction electrons are flowing through the conductor? What answer you are going to say? In which direction electrons are flowing through the conductor? So when two ends of a metallic wire are connected across the terminal of a cell, so negative terminal to, what will be the answer? Come on, quickly tell. So it is exactly positive to negative. Kartika, good evening. Kartika, good evening, beta. We will meet in Saturdays offline class, huh, Kartika? Morning itself. Appointment fixed with you. Conventional direction is positive to negative, and electron, they are not asking conventional. They are not at all interested to know the convention. See here, they are purely asking the cut-to-cut question. What is the cut-to-cut question they have asked? They said that when two ends of a metallic wire are connected across the terminal of a cell, some potential difference is set up between its end. In which direction electrons are flowing through the conductor? In which direction electrons are flowing through the conductor? What is the answer? Electrons are flowing through the conductor. They didn't ask about conventional direction of current. They are only wanting to know that which direction electrons are moving. And those who have told that answer, negative to positive terminal, they are absolutely correct. Shall we go back to the next question? Electric current flows through a metallic conductor from one A to B. End of the conductor is higher potential. Why? So this question you are exactly going to handle. Electric current flows through a metallic conductor from its one end A to another end B. Which end of the conductor is at higher potential? Why? Which end of the conductor is at higher potential? Which end of the conductor is at higher potential? Why? Which end of the conductor is at higher potential and why? Very good. So from the place, look here, one simple content is there. You have to just understand that electric current flowing through a metallic conductor from its one end A to another end B. Which end of the conductor is at higher potential and why? Which end of the conductor they are talking about? Which end of the conductor is at higher potential? So definitely current is exactly flowing from terminal A to terminal B. So just we are going to draw this one to know, okay, from terminal A to terminal B. So we are exactly going to start from terminal A to terminal B. So current will be moving from terminal A and electrons will be moving from terminal B. So if somebody will be asking you this question, that what answer you are going to say? Ki yes, current will be moving from higher potential. Higher potential means this one is taken as positive, that is higher potential to lower potential, and electron will be moving from lower potential to higher potential. Electron will be moving from lower potential to higher potential, that is exactly from this one to negative to positive. Okay, negative to positive. Fine. Now this question answer, out of these two wire P and Q shown below, which one has greater resistance? Justify it. Which one has greater resistance? Justify it. A given length of wire, which one has greater resistance? Which wire will be exactly having greater resistance? Which wire will be having greater resistance? Which wire will be having greater resistance? What is the reason behind it is having greater resistance? Very good, super, bang on. So here one very important thing is, you have exactly caught the question very correctly. Here everyone is given the correct answer. So here the correct answer is exactly going to be the Q1. What is the reason behind it? You see, both are having the same length. Okay, now you know that resistance is equal to resistivity L by A, rho L by A. So 100% when you are seeing that ki both are having same length, then it is exactly going to be totally dependent upon area of cross section. The one which is having a more area of cross section, because resistance is inversely proportional to area of cross section. If area of cross section will be more, then resistance will become less, and if area of cross section will be less, resistance will be more. So that means which one is exactly having more resistance? This one will have more resistance. So answer will be Q, and you all are bang on, absolutely correct. Super. Shall we go to the next question? A given length of wire is doubled on itself, and this process is repeated once again. Today evening I was discussing, this is CBSE 2011 question. This is CBSE 2011 question. So I want my bacha party to attempt this question very nicely. So only evening also some part of it I have discussed, and now again I am discussing that a given length of wire is doubled on itself, and this process is repeated once again. By what factor does the resistance of a wire change? By what factor does the resistance of a wire change? Come on, quickly say the answer. By what factor does the resistance of a wire change? The resistance of a wire change by what factor? 1 by 4 times, Kartika. Very nice try, beta. But one more time you have to try, Kartika. Because 1 by 16 time is the answer. 1 by 16 time is the answer given by whom? 1 by 16 times. So new resistance will be 1 by 16th of the old resistance. One shortcut method we have exactly done. So I am going to discuss this one. Kartika, check one more time, beta. Evening we have already done this one. Now look here. Now evening we have done this question. So that means wire will double itself. Double means double folding they are talking about. We are not talking about the length of the wire to be doubled. Means we are not talking about stretching the wire. Okay. We are just telling that a length of the wire AB will be there. Just think about it. So this is a wire, AB is there. Now this wire we are folding. So once you are folding the wire, from here you are taking the wire here. Now the length of the wire is doubled. So now AB is coming here. That means we just folded the wire. We just folded the wire. And again, beta, what you are going to do is, once you have folded the wire, now again refold it. Okay. Now Kartika, absolutely correct, beta. Again refold it. So again when you will refold it, then what happened? See, first the length of the wire was this much. Now you exactly folded the wire. Now the wire is exactly, this 2 wire is there. Now again you fold the wire. So now the wire will become only this much. See, one time folding of wire means this is wire, I am the wire, I folded, and then whatever is left, again I am going to fold it. So if I am again going to fold it, that means the length of the wire, so new length of the wire was L, now L1, and now the length of the wire, new length of the wire is 4 times 1 by 4 times of the old wire, beta, because here it is exactly folded 4 times. So since it is folded 4 times, the new wire, the length of the wire will be exactly 4 times the 1 by 4th of the original length. 1 by 4th of the original length. Absolutely correct, everyone. But beta, when all the wires are getting folded, now beta, the wire width will become more. That means initially the area of cross section of the wire was A. Initially the area of cross section of the wire was A. Now the area of, since 4 folds are there, so area of cross section of the wire was A1. Now what is the area of cross section of the new wire? It is exactly going to be 4 times, because 4 folds are there. So it is going to be how many times, beta? 4 times. So here it will become A2 is coming, new cross sectional area. So A2 will be 4 times of A1. Now you know what will be the first resistance. You know that resistance will be R1 will be rho L1 by A1. Resistance will be, because they are asking what will be the new resistance. Second will be, this one is exactly going to be rho L2 by A2. So now we are going to divide it. R1 by R2 will be equal to rho L1 by A1 equal to rho L2 by A2. So this and this will get cancelled. So R1 by R2 will be equal to L1. So I'm just writing L1 value is exactly this one. So I'm just not going to touch this one. L1 by A1 equal to A2 by L2 is coming. So now L1 is exactly, we don't know. So L1 we are keeping it as it is. But L2 is 1 by 4 of L1. L2 is 1 by 4 of L1. So L2 is 1 by 4 of L1. Check one more time. L2 is down, so 1 by 4 of L1. So L1 by L2 is coming. L1 by L2, if we will write L1 by L2, L1 by L2 will be coming 1 by 4. Okay, check here. It is going to be L1 by L2. L1 by L2 is coming as 4. L1 by L2 will be coming as 4. Now A2 by A1, A2 by A1, A2 by A1 will be coming as 4. So R1 by R2. So exactly R1 equal to R2 into 16. So new resistance will be 1 by 16th of the old resistance. So new resistance will be 1 by 16th of the old resistance. Good evening Arif, good evening Sudarshan. The correct answer is new resistance will be 1 by 16th of the old resistance. The answer is absolutely correct. We are going to go for some questions, beta. Next question is, now you answer this question. The radius of a conducting wire is doubled. What will be the ratio of its new specific resistance? Okay, what will be the, I think the question is exactly cut somewhere. So we will not touch this. Resistance of an incident filament of a lamp is comparatively much more than that when it is at room temperature. Why? You attempt this question. You attempt this question. Resistance of an incandescent filament of a lamp is comparatively much more than that when it is at room temperature. Why? What is the reason behind it? Bah, super, no problem. But we have discussed many things today. Now beta, go for this question, no problem Arif, but we have discussed things today in offline class. Resistance of an incandescent filament of a lamp is comparatively much more than that when it is at room temperature. Why? When it is at room temperature, what is the reason behind, beta? Heating effect of current, absolutely correct Kartika. In short, she has given the most important point. Very good Kartika, super beta. So now next, look here. Exactly, she is absolutely correct. You have to understand one thing, temperature is directly proportional to resistance. Very good. So H is equal to I square RT. So definitely Kartika has told that since we know that H is equal to I square RT, Joule's heating effect is there. So here one thing is there that when the bulb will be switched off, definitely there will be no what change in the resistance, but the moment here you know that resistance depends upon temperature. What are the factors on which resistance of a wire depends upon? Resistance of a wire depends upon length of the wire, area of cross section, nature of the material, and the temperature also. Increase in temperature increases the resistance. So here also the moment the bulb will be exactly switched on, the bulb will start glowing and it will heat up the filament, and once the filament will get heated up, what will happen? Its temperature will rise, and increase in temperature will increase the resistance. I repeat my point, please kindly see this one. Temperature is directly proportional to resistance. Incandescent means beta the one which is exactly having filament and it will be exactly burning beta. Okay, so same case Arif, the Kartika, Teja temperature is okay. Arif, oh, now look here. So again one more time I am just explaining this one beta. What happens that when you are switching on bulb, the filament of the bulb will start heating up. The heating up will exactly increase the temperature. As we know that resistance depends upon temperature. Resistance depends upon what? Resistance depends upon temperature. Resistance depends upon what? Resistance depends upon temperature. So since resistance depends upon temperature beta, what will happen? Increase in temperature will increase the will increase the resistance. Increase in temperature will increase the resistance. This is the only concept beta. Now why is manganese used for making standard resistors? These are a very important questions. I want my children to answer these questions very nicely. Beta, why is manganese used for making standard resistors? Today again in evening class we discussed about manganese. Manganese is a type of alloy. Now alloy, why we are using alloy? For making standard resistors. So standard resistors work is beta specific. We are going to go for standard resistors. So these standard resistors are exactly can produce heat and they can withstand temperature also. So that's why they are called as standard resistors. So why we are using manganese? So today I think Akshay or someone has given the answer very perfectly in evening. So I want that answer to be replicated here beta, because it is an alloy. Now Akshay, who has given that 3 points? I think Sudarshan, or who has given that points? Can you repeat that points beta? Very good. It can withstand high temperature because manganese is an alloy and it can withstand high temperature along with high temperature beta. One more thing, who has given that answer? It was perfect. Low temperature coefficient. Okay, Teja has given answer, super answer. Madhav, Sudarshan, high resistance, very good. They have high resistivity, low temperature coefficient, super Teja. So last point is oxidation state. We will talk about oxidation also. See beta, we are not going to leave oxidation rate. So definitely they have high oxidation rate or low oxidation rate. So oxidation rate will be high or low. That point also we will be considering. Fine. It does not oxidize. Very good. So it is exactly not going to oxidize, means it will not catch fire easily. So since it will not catch fire, means it can withstand high temperature. Means you can increase the temperature, you can increase the amount of current flowing in the circuit. Then what will happen? Either you are increasing the current or you are increasing the temperature. Then too it can withstand that and it will not break. It will not break. So that's why beta we are using it. So very good answers. All 4 of you has written all the points specifically correct. Very good. So now we are going to go for the next question. Better try this question out. What is the question? They are telling that a resistance of 1k ohm has a current of 0.25 ampere throughout it. When it is connected to a terminal of a battery, what is the potential difference across the end of a resistor? What is the potential difference across the end of a resistor? What is the potential difference across the end of a resistor? I know my bacha party will definitely be able to solve this question. So beta, ohm is there, but here they have given k ohm, 1k ohm. Beta, 1k ohm will be equal to how much ohm? Very good, Kavya. Kavya has given the answer 0.25 volt, 250. Kamya has given as 250 volt. So this is a change. Where is Arif, Sudarshan? Where is the answer, beta? Start giving the answer. Ajay, Arif, Sudarshan, morning, evening class, many were giving so super answers. Now tell me now. Kamya answer 250. Shiva answer is 250 volt. Now let's check this one, Shiva. Answer is correct or wrong, beta? Very good, Kamya. That is 250 volt is correct. Correct. So now look here. You know resistance is given as 1k ohm. So 1k ohm means 1000 ohm. Now current is exactly given to you as 0.25 ampere. So we know that V is equal to IR. So no big deal. I is exactly 0.25 into 1000. So it is coming 25123. So that is 250 volt. 250 volts, absolutely correct. 250 volts, those who have given 1K is 1000, absolutely correct beta. Shall we go for the next question, that ki calculate the current in a circuit if 500 coulomb of charge passing through it in 10 minutes. If 500 coulomb of charge passing through it in 10 minutes. If 500 coulomb of charge, calculate the amount of current if 500 coulomb of charge passing through it in 10 minutes. I am just moving from here. Tell the answer beta. क्या हुआ सार्थक, कहाँ था तुम अभी तक? Where were you सार्थक? Absolute, very good. Sudarshan, Akshaya, Kavya, Kaushika, absolutely correct beta. So exactly question was what? So 500 coulomb of charge is given and it is passing through a current in 10 minutes. Beta, shall we convert minute into second? No problem beta, video फिर से देख सकते हो. Shall we convert minute into second? So here 10 minutes means 10 into 60 seconds. So it is exactly going to be 600 seconds. So now you know that current is equal to I is equal to Q by T. So charge is given as 500 and current time is given as 600 seconds. So that means it is going to be 5 by 6 ampere. 5 by 6 ampere is absolutely bang on answer. Kamya, 5 by 6 ampere is absolutely correct answer beta. Now shall we go for next question? How will the resistivity of a conductor change when its length is tripled by stretching it? When a battery is connected to a closed circuit, charge flow in the circuit almost instantaneously. Explain. So the first question is, how will the resistivity of a conductor change when its length is tripled by stretching it? So first part of the question, say the answer beta. How will the resistivity of a conductor? How will the resistivity? Sudarshan has given the answer first. So how will be the resistivity of a conductor will change if we are changing the length of the conductor. Length of the conductor is exactly tripled. It remains same, no change. Akshaya, super, very good. So Kartika, remains same, absolutely correct beta. Resistivity has no change, very good. Why the answer they are telling is no change? Because you increase the length, decrease the length, increase the area of cross section, decrease the area of cross section. This will only create an impact on resistance. But resistivity is the intrinsic property of a conductor. Resistivity only depends upon nature of the material and the temperature. So temperature change and nature of the material will only be influencing resistivity. Rest other than that, it is exactly not going to do any big deal. Okay, fine. So that means it is not going to change anything. But beta, next part of the question, what they are telling that, get ready to answer this question. When a battery is connected to a closed circuit, charge flow in the current almost instantaneously. Explain. I think I have explained this point. Can you tell me in short? Because few minutes before itself we have discussed this point and I want you all to just answer this question. Few minutes before itself we have discussed this point. So can you explain this one beta? Can you explain this one? What happened? How will the resistivity of a conductor change when when a battery is connected to a closed circuit, charge flow in the circuit almost instantaneously. Explain. What can be the beta? What can be the, right now before itself we have discussed this question. Tell me what answer it is exactly going to be. What answer? What answer? What answer? I'm just moving from there so that it is not going to create problem for you. What answer beta? Very good Akshaya, that was non-dependence temperature. Calculate the amount. What is the question is, when a battery is connected to a closed circuit, charge flows in the circuit almost instantaneously. Means the moment you are beta connecting a battery to a wire connecting with bulb, the moment it is connected beta, you are switching on, instantaneously current started flowing. Okay, it's not like beta it is taking so much of time to glow. It is not like that na. So like torch and bulb now, what you are doing beta, torch and bulb, what you are doing, the moment you are switching it on, it has started glowing. Yes or no? So Darshan, answer. In closed circuit, potential difference would be created due to chemical reaction in battery. So due to its current start flowing. So Darshan, bang on beta, bang on. Victory moment for me. So exactly, yes, the most important, I think due to difference in speed, I am getting the comments quite late. So only I think my children has not given the comment, but I am quite sure they know the answer. The thing here is till now only Sudarshan answer I have got. So the most important point here is that beta already we discussed now, potential difference means what? The moment battery or cell is connected with the circuit, battery or cell is connected with the circuit, what happens? The current starts flowing in the circuit. Now since the current start flowing in the circuit, chemical reaction start taking place. First we will start with chemical reaction start taking place in the battery. Now this chemical it will exactly allow the electron to move from negative terminal to positive terminal. So this movement of the electron from negative to a positive terminal will allow the current to flow, and that is what the Sudarshan has given, that the potential difference generated means the difference between the positive terminal and the negative terminal. Means once the wire is connected to battery or cell, then what happens? There will be a difference in the terminal, and this difference in the terminal instantaneously allow the current to flow in the circuit. This difference in the terminal instantaneously allow the current to flow in the circuit. This is a very important point. Now shall we go for how will resistivity of that question we have discussed. Now beta, go for this question. An electric iron draws a current of 0.6 ampere when the voltage is 100 volt. Calculate the amount of electric charge flowing through it in 1 hour. Calculate the amount of electric charge flowing through it in 1 hour. Calculate the amount of electric charge flowing through it in 1 hour. How much amount of charge it will flow beta? Charge baba, Kartika, charge beta. Charge you have to find. Charge you have to find beta. Check one time. Charge beta, charge you have to find. How much amount of charge? 2160 Coulomb. Yes. 216 correct only, Kartika. Just check that beta, it will be charge. So now look here beta. You know that current equal to I is equal to Q by T. I is equal to Q by T. I is equal to Q by T. Now current is already given you 0.6 ampere and time is given you 1 hour. Into 1 hour is equal to amount of charge flowing. So in 1 hour beta, we have to convert that into seconds. Okay, so 0.6. So here 60 into 60 will come equal to Q. This is the amount of charge will be flowing. So here 66, 36, 216. So 21600. So after one decimal, so here it will be how much beta? 0.6, this much Coulomb. So 2160 Coulomb. 2160 Coulomb. 2160 Coulomb of charge. So absolutely correct beta. Here one thing you have to understand beta, here voltage we are not at all considering. So directly means you can use any formula, but here very shortcut formula is there, that is I is equal to Q by T. Then why to go for voltage and what you call waste our time? So we have just used it directly. Right relation between heat energy produced in the conductor when a potential difference V is applied across its terminal and a current I flows through it for time. What will be the relation beta? What will be the relation here? What will be the relation? You know the direct relation. Very good Shiva, very good Shri, very good Shri Bhavani, very good Kamya. Absolutely correct. Now it is correct. Kartika, now correct beta. Now shall we go for the next one beta? Right relation between heat energy produced in a conductor when a potential difference V is applied across it and terminal and current I flows through it at time t. You know the relation na, V is equal to H is equal to VIT. Absolute beta, H is exactly equal to VIT. How many of you are writing H is equal to VIT? Absolutely correct beta. H will be exactly equal to VIT. Okay. H is equal to VIT. Now shall we go for the next one? Shall we go for the next one? Now question is, why the bulb get fused if it is operated at higher potential than its power rating? When it is operated at higher potential than its power rating. This is a normal question now. Every time we are encountering this question. Every time now we are encountering this question that ki aunty, you know what, I applied a bulb aunty, and you know what, 220 volt it was written, and the moment I applied it with another volt, then definitely the bulb got fused aunty, it got busted aunty, and it is exactly sound was coming there. So that sound effect was there aunty. So exactly this, why this happened? So just tell me what answer you are going to say about it. I'm just moving so that you can give the answer. Why the bulb get fused if it is operated at higher potential than its power rating? So whatever power rating is there, accordingly exactly we are just going to use it. Otherwise we are not going to use it. Auntie, fuse, melt, cause more power, more heating, burning, all death. To protect the current and appliances. Very good. So beta, if somebody will be asking you then how to give the technical answer, right now itself na you said na ki aunty H is equal to VIT. H is equal to VIT, right now itself you have said na H is equal to VIT. So if I am going to, and you know that V is equal to IR. So if I am going to write IR there, is it going to be doubled? H is equal to, or can I write H is equal to V square by R into T? So here potential difference means the moment potential difference will be doubled beta, potential change means definitely heat generation will be more. Definitely heat generation will be more. This is a very, that means more heat will be produced, more bulb will be operated at higher potential, then more than its power rating, then the bulb will get fused. More than its power rating, if more it will be generated, then the bulb exactly going to get fused. It will get fused. Fine. So H is equal to V square by T, V square by R equal to T. So V directly proportional to P. So higher potential, higher power than its capacity resulting is fused. Absolutely correct, Sudarshan. Nailed the point. Okay. Now next question is this one. List the factors. Now this is exactly the question which 2018, if you will see the question, this question came in CBSE 2018. So only I have compiled, this is all exactly question known. List the factor on which resistance of a conductor in the shape of a wire depend. In the shape of a wire depend. List the factor on which resistance of a conductor in the shape of a wire depends. In the shape of a wire depends. What are the factors beta? Just talk about the factors only. Talk about the factors. So list the factor on which the resistance of a conductor in the shape of a wire depends. You already know the points. You are genius and you are exactly P is equal to VI. Absolutely correct, Sudarshan. Directly proportional, absolutely. Length, area, correct Akshaya. Area, temperature, length, nature of the material. Bang on. Super. Super Kamya, Kavya, length, area of cross section, temperature, length, area of cross section, Kartega, length, cross section, area, temperature, material of the conductor. That is the nature of the material of the conductor. Bang on here. So length, area of cross section, temperature, area of cross section and temperature. Absolutely correct beta. So if somebody will be asking you that on what factor resistance of a material depends upon. So here you just check this one out. R is equal to rho L by A. Now R is what? Rho is what? Resistivity. Now resistivity depends upon what? See, R is looking forward for all the three. R is looking forward for resistivity also. R is looking forward for length of the wire also. R is looking forward for area of cross section of the wire also. So that means one simple point here to be noted that resistance of a wire depends upon nature of the material, temperature of the material, length of the wire, and area of cross section. So this 4 points we are going to write. Now shall we go for the next question, beta? Why are metal good conductor of electricity whereas glass is a bad conductor of electricity? Give reason. I think you know what is free electrons. Like Kardega, super yaar. One chocolate for Kardega. So 100% nature of material, yes. So the most important point here is कि when we are talking about metals have free electrons. Okay, the presence of free electrons is exactly making them more the presence of free electron. These free electrons will be able to carry current, and because of that they are good conductor of electricity. But glass are bad conductor of electricity because they do not have free electron. Since they do not have free electron, because of that they are bad conductor of electricity. Why are alloys commonly used in electrical heating devices? Give reason. So this question answer, I know my children will be able to answer. Few minutes back itself we have discussed this point. Why are alloy commonly used in electrical heating devices? Why we are exactly using alloy? Very good. It is having high melting point. Absolute. Next point, high melting point. Next point. Come on, tell me. Very good. That's the point which I was exactly looking forward for. Alloy don't oxidize at high temperature. Oxidize at high temperature. Kavya, correct. Because of free electron do not get oxidized. High resistivity, high resistance, high melting point. Karthika has given answer for both of that. Super. So exactly the answer is absolutely correct. Okay, now high melting point, not oxidize, high resistance. That's the most important point. Now define 1 volt. Very rarely we are seeing this type of question, and if you will see, this question came in cbse 2014. Very rare this question. Define 1 volt, express it in terms of SI unit of work and charge. So when you will be exactly expressing volt, so the definition should be expressed. So see, look here, they are telling define, and after that they are giving the condition that you have to define in terms of work and charge. So both the conditions they are just implementing. So what answer you are going to write about 1 volt when you are explaining in terms of charge? When you are exactly explaining in terms of charge. So 1 joule of work is done in moving a unit charge from one point to another. Very good. So when 1 joule of work is done in carrying 1 coulomb of charge from infinity to that point in the electric field. Absolutely. Then potential at that point is called 1 volt. Absolute correct. Then potential at that point will be exactly called as 1 volt. So amount, how much amount is exactly 1 joule of work is done in moving 1 coulomb of charge. 1 coulomb of charge from infinity to that point. From infinity to a point in the electric field, then potential at that point. Is called as 1 volt. Now calculate the amount of energy consumed in carrying a charge of 1 coulomb through a battery of 3 volt. What answer is exactly going to come? Tell me about this question. Means here what type of answer we are going to expect? What answer we are going to expect? We know that potential will be equal to work done by amount of charge flowing in the circuit. Potential difference will be equal to amount of work done by amount of charge flowing in the circuit. Potential difference will be equal to work done by amount of charge flowing in the circuit. So now calculate the amount of energy. So work done will be equal to potential difference into this. So now definitely potential difference is exactly given as 3 volt and charge is 1 coulomb. So what answer is there? What answer is going to come? Yes, absolutely yaar. Why they have asked this question? See, CBSE 2014 they have asked this question. So what we are going to say? See, one definition and one part which was exactly very easy. We felt that the question is tough, but see, you have to just understand this point and you have to just say the answer. Now beta, one question is there. Draw a closed circuit diagram consisting of a 0.5 meter long nichrome wire XY, an ammeter, a voltmeter, 4 cells of 1.5 and each and a plug key. So they will give you like this type of question. What is the reason behind adding this question in the point that they are exactly telling you to draw a circuit. They are exactly telling you to draw a circuit. Now how to draw a circuit? Draw a closed circuit diagram consisting of a 0.5 meter long nichrome wire. So 0.5 meter long nichrome wire we are going to use. 0.5 meter long nichrome wire we are using, that is XY, and now this XY will be exactly connected with an ammeter. Now cell now 4 cells, 1 2 3 4. So 4 cells we have exactly connected, each and a plug key is connected, fine. Along with that they are telling that each cell is 1.5 volt. So 1.5 into 4, 4 5s are 26, so that is total overall 6 volt is coming. Overall how much volt is coming? 1.5 into 4, so overall 6 volt is coming. Come on, quickly tell me, overall 6 volt is coming or not? Overall 6 volt, 1.5 means 4 5s are 21, overall 6 volt is coming. So this point we have done. We should draw voltmeter across XY and T. Yes, we have not drawn the voltmeter. I think I missed voltmeter. Thank you, Sudarshan. So voltmeter across XY. So today itself we were discussing about, so only I was discussing about where to place the voltmeter, In the evening class itself we were discussing about it now, where to place the voltmeter. What is the placement of the voltmeter? The placement of the voltmeter is here across XY. It is exactly here. Where? It is exactly across XY. That's it. So this, now following graph, now one graph they have plotted. Now just see this graph. I think half question is there. Okay. So it's time, 2 questions are left. So tomorrow morning with these 2 questions, more questions, yes, that question is incomplete, so I'm just keeping it till here. Tomorrow morning we are exactly going to do more questions. Tomorrow maths, rather than maths, we are going to have a physics class, and in physics, electricity, numericals we are going to discuss. Okay, I hope you might have enjoyed today's class, and more numericals tomorrow also we are going to do better. So good night everyone. Fine.